Welcome everyone in this session. We are moving ahead with this topic in this chapter current electricity. The topic name is Ohm's law. So in Ohm's law, at constant temperature for a given dimensions of a conductor, the strength of electric current through a conductor is directly proportional to the potential difference applied across the conductor. Let V be the potential difference applied across the conductor and I be the current flowing through it. According to Ohm's law, then, I is proportional to the V. So, I is equals to 1 by R times of a V, where R is the electrical resistance of the conductor. So, what is the resistance here? The ratio of the potential difference across the end of the conductor and the current passing through the conductor is said to be resistance of the conductor. That means resistance R is equals to potential difference V divided by current I. The unit of a resistance is a ohm, which is equals to volt per ampere. The dimensional formula for this is ml to T minus 3 A minus 2 ohm. So, if V is equals to 1 volt and I is equals to 1 ampere, then R is equals to 1. The resistance of a conductor is said to be 1 ohm. If 1 ampere current passes through a conductor having a potential difference of 1 volt across its end, so the symbol of a resistance. So this is a symbol of a resistance, symbol of a variable resistance. So if we do a variable resistance, if we want to present a variable resistance, so the symbol of a resistance is this. This is a for variable resistance. Over here, this will be not present. So this will be the symbol of a variable resistance, only this. Moving ahead, if this will be electrons and which have a polarity negative and positive, and that charges wants to move over there because of ions or atom. This is the electrons. So fundamental understanding of a resistance of a wire is opposition to the flow of a current in a conductor due to the collision of electrons with the ions and atoms of a conductor, termed as a resistance of the wire conductor. Factor which is influence the resistance of the wire, that means nature of the material, specific resistance rho, directly proportional to the length of the wire L, inversely proportional to the area of a cross section capital A. Temperature of the wire T. So we can say that R is equals to rho L by A. So for additional knowledge, we know Ohm's law is neither a basic law nor a derivable one. V is equals to IR, just an empirical relation. Microscopically, Ohm's law is expressed as a V is equals to I L by sigma A, where sigma is the electrical conductivity of the material. We can represent as in J is equals to NEVD or J is equals to sigma E also. When potential difference is applied to the end of the conductor, free electrons get accelerated. As they move, they collide against the atom and ions, and thus their motion is opposed. The opposition offered to the flow of a charge through a conductor is called resistance. And the resistance of a conductor depends on the nature of the material, dimensions of the conductor, and physical condition like the temperature. So pressure and dimensions like strength, length, cross-sectional area, etc. are these. What is the mean of a conductance? The reciprocal of a resistance is called the conductance of the conductor. That means conductance G is equals to 1 by R. The SI unit of a conductance is a mu or ohm inverse or sine, and the dimensional formula is M minus 1 L minus 2 T3A2. Limitations of Ohm's law. Although Ohm's law has been found valid over a large class of a material, there do exist few materials, devices used in the electrical circuit where proportionality V and I does not hold. The derivation broadly are one or more of the following types. First, V cases to proportional to I. The relation between V and I depends on the sign of V. If I is the current of a certain V, then reversing the direction of a V, keeping its magnitude fixed, does not produce any current of the same magnitude as I in the opposite direction. So, this is a graph. V and I. The dashed line represents the linear Ohm's law. The solid line is the voltage versus current I for a good conductor. Characteristics curve of a diode. So this is a characteristic curve of a diode. As you can see, this line is also not straight. So we can say that for this is not following the Ohm's law. Next, we have this type of a graph. It is also straight at some point, and after that this will be non-linear, and then after this will be negative resistance. So this is also not following the Ohm's law. The relation between V and I is not unique in each the cases. That is, there is a more than one value of a V for the same current. Material exhibiting such kind of a behavior in gallium arsenide. Material and device not obeying Ohm's law are actually widely used in electrical circuit. Ohm's law is not a fundamental law like a Newton's laws, as it is not obeyed by the all substances. It is an empirical formula just to use to find the potential difference across the conductor. Ohm's law is valid only for the linear conductor, in which V versus I ratio is a constant such materials or metals. Now moving ahead with some MCQ questions so that we can able to understand those things we studied. Have we understood or not? So the first question we have, at a constant temperature for a given dimension of the conductor, the strength of an electric current through a conductor is dash to the potential difference across applied the conductor. We have these options: directly proportional, inversely proportional, equal, not equal. The correct answer for this question is directly proportional. Next question we have, the symbol of a variable resistance is. So the correct symbol of a variable resistance is option B. Next topic we have ohmic and non-ohmic conductors. Ohmic conductors. The substance which obeys the Ohm's law are called as ohmic conductors. Example metals. For a linear and or oblique conductor, I versus a V graph will be straight line. That means slope tan theta gives I by V, which is a 1 by R is equals to G. G will be the conductance. Again, if I'll just make the graph for a V versus a I, so this will be give the resistance. I versus V, conductance. And V versus I, resistance. Non-ohmic conductor. Substance which do not obey Ohm's law are called as a non-ohmic substance or non-ohmic conductors. For example, electrolytes, thermionic valves, thermistor, semiconductor, vacuum tube, and transistors. These are like an example of a non-ohmic substance. A thermistor is a non-ohmic device which is a VI curves. For transmitter is shown in the graph. For the same value of a V, there will be more than one value of a current found. This is a thermistor. V versus I or VI curve for a semiconductor PN junction diode is shown. Here, again the curve is not straight line. That's why we are saying we can say that this graph is also non-ohmic. VI curve for a vacuum tube is not a straight line, as you can see. So we have a move another particular questionnaire part. So Ohm's law is applicable to ohmic conductors only, non-ohmic conductors only, both ohmic and non-ohmic conductors only, and vacuum tubes only. The correct answer for this question is option A. Next question we have the resistance of a conductor is inversely proportional to the length, directly proportional to the length, inversely proportional to the square of the radius, directly proportional to the square root of the length. The correct answer for this question is option C. So this is all about for this particular topic. Thank you and take care of yourself.